Hello and welcome back to Carto Geospatial Solutions. So in this video, we're going to do some satellite image analysis. So we're going to compute the Normalized Difference Vegetation Index for our study area for say 3 different time periods. And then we're going to compute the NDVI for 4th time period using the regression analysis. So before moving on, first we need to understand what this term NDVI means and what are its usages. We'll first look about that. So this Normalized Difference Vegetation Index is one of the many vegetation indexes which are used to remotely sense the amount of vegetation in an area. So this NDVI in particular makes use of two bands from any given satellite sensor, and these two bands are the near infrared band and the red band. So its main aim is to estimate the amount of density of vegetation in an area of interest. And as I already said, it makes use of only two bands, and these are the near infrared band and the red band from a given satellite sensor, which are captured from a given satellite sensor. And the NDVI values normally range between -1 and +1. And before that, this is the formula which we use to compute the NDVI. So it is the near infrared band minus red band divided by near infrared band plus red band. Using this formula, you'll be getting the values for an area of interest, and these values will be ranging only between -1 and +1. So this -1 indicates that our place of interest is a water body, or it is a place which is completely devoid of vegetation. And whereas if we progress from -1 to 0, it indicates that our place of interest has somewhat a bit sparse vegetation. And as we progress further from 0 to 1, it states that our place has a good to very good amount of vegetation in it. Okay, so and even though there are many vegetation indexes in this domain, this one is predominantly used because of its simplicity. As we just saw now, the formula which we use to calculate this NDVI is very simple as compared to other indexes like the Soil Adjusted Vegetation Index and the Enhanced Vegetation Index. These kind of indexes can be computed using the formulas that are a bit complex in nature as compared to this NDVI formula. So it is no wonder that this NDVI is more commonly used as compared to them because of its simplicity in calculation. Having understood what an NDVI is now, we want to see how to compute the NDVI using the ArcMap software. So first let me open the ArcMap software. So I have already downloaded the satellite data required for this computation from the Earth Explorer website. And if you want to know how to download them, we can have a session on that later. So this is the data which I have already downloaded from the website, and the data which I am going to use is the Landsat data. So I have taken 3 time periods here. So it is 2011, 2016, and 2021. So we are going to compute the NDVI for the year 2026 using the regression equation. So first let me add the data here. So first let us compute the NDVI for the year 2011. So this 2011's data has data from the Landsat 5 sensor, which indicates that band 4 represents the NIR region and band 3 represents the red region. So it is always very important to note the type of sensor which we are using because the band combinations would vary based on the sensor which we are using. Say for instance, if it is a Landsat 5 data, the band combinations will be 4 and 3 for NIR and red. And whereas in the case of Landsat 8 data, it will be bands 5 and 4 for NIR and red respectively. So it is very important to keep that in mind before doing the analysis. So first let me add the desired bands on the canvas now. So the bands which we desire is band 4 and 3, right? So let me add band 4 and band 3 onto the canvas. In order to compute the NDVI, we just need to open the raster calculator. So let me open that tool first. You can also search them from here. So let me open the raster calculator. Okay, so we're going to compute the NDVI for this 2011 year. As you can see here, the data which I've added were given here. We're going to just employ the formula which we learned earlier. So before doing that, we have to add an operator here, which is the float operator. So the reason why we add this float operator is that we have to get the values in the decimal places. Okay. Should we ignore the float operator, then we'll be getting the values which are very discrete in nature and which can severely hamper our analysis. So if you want to do a proper analysis, then we need to adopt the float operator before the NDVI formula. So let me add the float operator here. So now we need to incorporate the formula inside this. So it is NAR minus red by NAR plus red, right? So it will be band 4 minus band 3, right? Divided by slash, again you have to add the float operator here, float of band 4 plus band 3, and you can save it in your folder of interest. So let me save it in a folder. Okay, so let me save it here. Let me give the name as NDVI underscore 11.pip. Okay. So as you can see here, we have got the NDVI data for 2011 year. Let me just uncheck these two bands. Okay, so you can see the data here. So let me just change the symbology, which is more appropriate for representing the NDVI. So NDVI can be presented using this color scale, that is from brown to red. So this brown stands for low NDVI region, and this green stands for higher NDVI value regions. So, by giving that, you can see the difference here. We can safely assume that this place is a water body. It is more of actually a dam. As you can see, it is having a mouth here. And you can also see a river that is flowing towards the Bay of Bengal region. Because the place I have taken is in the southern part of India, so it forms a part of a district named the Perambalur district in the state of Tamil Nadu. So this river is proceeding towards the Bay of Bengal coast, right? So you can also see a small lake-like thing here. So and you can also see some dense vegetation here. This indicates the fact that these places are more of a forested area. So in the same manner, we are going to compute the NDVI for the two other time periods. That is for 2016 and 2021, right? So I've calculated the NDVI for the two other time periods as well. You can see here, I have calculated for the years 2016 as well as 2021. You can see the difference between them. Okay, so now we are going to clip this data according to your study area. So as I already said, our area of interest is Perambalur district, which is in the state of Tamil Nadu, India. So we're going to clip this data according to our extent of study area. So this is the shapefile of our study area. It is the district of Perambalur. Okay. So for that, we're going to use the raster clip tool. So let me search for that. It is inside this data management toolbox. You can see that here. So first I'm going to give the input as 2011 NDVI data. So I'm going to clip that according to my Perambulu shapefile extent. So let me give the extent as a Perambulu shapefile. And it is always very important to check this particular option, because only then it will be clipping according to our shapefields boundary, or it will be clipping the data according to a rectangular extent. Let me save it in the folder. So it will be study area 11.diff, right? Let me give the node data value as -9999. And you can also check this option. This is a maintain clicking extent. So it is important to check both these options before proceeding with the OK button. Okay, so just enable this option and then just click OK. So you can see here it has been clipped here. Let me just close. Let me just turn all the layers off so that we can see only the clipped layer. You can see it has been clipped here. So let me change the symbology. And let me just zoom this study area to a full extent. So you can see that it has been clipped. So in the same manner, we are going to clip the data for our 2016 and 2021 time periods. As you can see, I have extracted the data according to the clipping extent for the 3 periods. So now comes the interesting part. So what we're going to do now here is that we're going to extract the NDVI values for the reserve forest areas inside this Perambulu district. So for that, I've already collected the reserve forest shapefile areas, okay, that are falling within this district. So let me just add those reserve forest areas first. So these were the reserve forest places that are lying within the district of Perambulu. So as you can see, there are totally 9 reserve forest places inside this district. So let me add them all. Okay, so as you can see, there are 9 reserve forest areas. So now what we're going to do is that we're going to find out the mean center for each of these reserve forest areas, and then we're going to extract the NDVI value for all those mean centers for these 3 different time periods. So you have to create the mean center for each of these reserve forest shapefiles. So for that, you have to use the mean center tool. So let me go to the search option again, and I'm going to type it. I'm going to type mean center here. Okay. So this is the tool which I want to use. Okay. So the main purpose of this tool is to find out the mean center, okay, within a particular shapefile. So first let me create a mean center for one reserve forest. Let's say for this one, Avarampadayam reserve forest. Let me create a new folder. Let me create a new folder inside the folder which we are already working on. So let me create a new folder, say points. And I'm going to create the mean center for this reserve forest, so which is Avarampadayam. So let me create it as Avarampadayam. Okay. Okay. So that's it. So just click on OK. So for doing that, you'll be getting a point shapefile. Okay. So as you can see here, it has been created. So it has created a mean center for this reserve forest. So in the same manner, you have to create mean centers for all these different shapefiles. So computed. Now we are going to merge all these point shapefiles into a single shapefile using the merge tool. So we're going to use that merge tool. So let me just type search for merge here. So it is inside this data management toolbox. So we're going to add all these nine different shapefiles as the input data sets. So I've added all the 9 different shapefiles here, 9 mean centers. So let me save it in the folder as points. Okay. So as you can see here, it has been merged into a single shapefile. So we're going to use this merged shapefile to extract the NDVI values for the 3 time period. Extract the values from the 3 data. We're going to use the extract multi-values to points tool. So we're going to search for the tool. So to extract multi-values to points. So in this case, we're going to give the merged point shapefile as the input point feature. So it is a merged points as input point feature. So we're going to give 3 NDVI data as input rasters. So it will be studied 2011, 2016 and 2021. Okay, so let me just click OK. So it has run. So if you open the attribute table of this merged point shapefile, you'll be able to see the NDVI values for the 3 periods. Okay, so as you can see here, you can see the values here. So now we're going to convert this shapefile into an Excel file. So only then we'll be able to do the regression analysis. We're going to use the table to Excel tool to convert this shapefile into an Excel table. Okay, so this is going to be the tool which we are going to use. So you just have to add the merged point shapefile as the input table here, and then you have to save it in a folder of your choice. So let me save it here inside this as merge. Okay, it's been converted into an Excel file. So let us open the file in the Microsoft Excel software. Here, this is the Excel file, and you can see the NDVI values for each different reserve forest shapefiles. So these are the values that are being extracted from the mean centers, which fall within the respective reserve forest shapefile. So now we are going to compute the NDVI value. That is, we are going to estimate the NDVI value for the year 2026 using the regression analysis. So for that, we have to first create a chart. So first, let me insert a chart. So just go to insert option, and then go to this scatter option. Click on the first icon. So you can see first we'll be getting an empty canvas like this. So just right click on this, then go to this select data option here. So now we are going to add the data based on which the chart will be created. So for that, you have to just select the first 2 rows here. So we're going to create a scatter plot in which the x-axis represents the time period, that is 2011, 2016 and 2021, and the y-axis represents the NDVI values. So the x-axis will be the independent variable, and the y-axis will be the dependent variable in the regression equation. So for that, first you have to just select these 2 rows here. Okay, since we are going to do the analysis for the Udumbiam Reserve Forest first. Okay, so it has been selected here, and you can see that the data has been plotted already on the graph. So we have to just make some changes in the x-axis values, because it has been represented in the decimal values, but it should not be. It should be discrete in nature. Since it is representing the years, it should be discrete. So for that, you have to just make some changes in the x-axis values. So let me just click OK here. So just go to the x-axis values here. Double click on it. Okay, so you'll be getting a box like this. So in this, you have to just fix the maximum value as 4. Okay, because we're going to compute the NDVI value for the 4th year. Let's say 2011 represents the first year, 2016 the second year, and 2003 year, 21 the third year. So in that order, 2026 will represent the 4th year. So a maximum value in this case will be 4. Okay, so then we're going to just fix the major unit to 1. So, so in that case, we'll be avoiding the decimal values in our data. So with that said, you can see the difference in the graph now. So now we have to compute the regression equation for this particular study area, which is the Woodingham Reserve Forest. So for that, you have to just select this option inside the design layout. So you have to get inside this design tab here. Inside that, you have to click on this option. So by doing that, you'll be automatically generating the regression equation. So as you can see, it has already generated the regression equation here. So as I said earlier, term x represents the independent variable, okay, which is the year, and the term y represents the dependent variable, okay, which is the NDVI values. And see the r. You can also see the r square value here. So this r square value is an indication of the dispersion of the data. That is, it is a measure of taking into account, let's say, how well dispersed the data is. So in this case, it is having a value of 0.66, which states that the data is not that much dispersed, and it is according to the regression equation line. So it is not that much variant in nature. So as the R-square value decreases, the amount of dispersion in the data points increases. So please keep that in mind. So the greater the R-square value is, the lesser will be the amount of dispersion among the data points, right? The NDVI for the year 2026. Okay, so it's very easy. So I just have to take this equation into account here. So as I said earlier, the year number 3 represents 2021 data. So if you want to compute the estimate, if you want to compute the NDVI value for 2026, then you have to assume that the x value is equal to 4. So so by keeping that in mind, just open the calculator. So it will be 0.0682 multiplied by 4, right, plus 0.1486. So this will give us the value of NDVI 6. So which means that y is equal to 0.4214. So this will be the value for 2026. So you can just write down the value here. So in this manner, you can also compute the NDVI for forest. So for that, you have to just make some changes in the graph. So just right click on that graph and then go to select data. So now we have to select only the first and the third row. Okay. So it will be the first row, and then press Control button and select the third row. So as soon as you do that, you can see the change in the regression equation here, right? So just press OK. You can see the R-square value is also increased, which states that the data is not that much dispersed, and it is very well correlated, and it is very much coherent. So in this case, should we use the value of x as 4, we'll be getting the value of y. So it is 0.065 multiplied by 4 plus 0.105. So it will give us a value of 0.365. So the value for Pulambadi Reserve Forest for the 2026 is 0.365. Calculate the NDVI for all the other reserve forests here using the appropriate regression equation for each and every trend, and as you can see that it is for the Perakambi Reserve Forest, that is this one. It has got a very low NDVI for the year 2026. So this particular reserve forest needs more attention as compared to the rest of the forest. Even though you can see a slight increase in the reserve forest NDVI for the year 2021, it is more prone to decrease in the coming years. So this reserve forest needs more attention. You can also see that reserve forest spatially. This particular forest needs more attention. So you can do these kinds of insightful analysis using the spatial data, which can be really useful for many government agencies. This kind of analysis is very useful to estimate the future trend of a particular area of interest. So I hope this analysis was of some use to you. Please do stay connected with us, and please do subscribe our channel for more interesting contents like this. So thank you so much for watching. I will stay in touch. Thanks again.